Alright, Professor Aguilar and I have been talking about operational amplifiers. Let's look at section 5.1 operational amplifier terminals. It's a very interesting topic. So this is the first time I'm introducing the topic of operational amplifiers. Couple of things that you want to remember is you want to understand as opposed to memorize. You don't want to memorize these. Some of the students find this operational amplifier topic to be challenging because they have a tendency to want to memorize. Don't do that. Understand the math. Particularly, we are going to be doing a lot of math. Okay, we're going to be doing a lot of mathematics. A little bit, nothing new that you haven't seen yet, but through all the mathematical manipulation, you want to make sure that you understand step 1 to step 2. Once you understand that, it's really going to be a straightforward topic that you will enjoy. Okay, so that's the thing you want to remember. Now, let's see. Operational amplifier is a 3-terminal device. Say 3-terminal device. Okay, so here is the symbol for an op-amp. Okay. The symbol for op-amp is simply the symbol for an op-amp is simply a triangular form, okay, with 2 input terminals. Remember, this is a 3-terminal device. 2 of the 3 terminals are input terminals. One of the terminals is output terminal. Okay, so let's name the output terminal first. Okay. I use Vout or VO interchangeably. Okay. One of the input terminals is labeled as negative. The other input terminal is labeled as positive. Okay. Now this guy, this negative terminal, okay, that guy, we like to call it as inverting. Input. Okay, I show it as VN, or sometimes I even show it as V negative. Okay, so VN is called the inverting input. Similarly, this guy VP, okay, VP, that terminal right there is called a non-inverting input. Okay, now, so these are the 3 terminals. That's it. Very interesting device. Of course, it does not function free of cost, so you have to supply positive power supply plus VCC, and also negative power supply, negative VCC. So these are DC voltages. Okay, these are not really inputs. This is just power supply. Okay, plus VCC and minus VCC for the power supply. The one thing that you want to remember really is the relationship. Well, it's not even remembering it. If you understand this, the relationship between V out and V positive, V negative. These are the inputs, right? Here are my inputs. What is the relationship between output and input? Okay, simply in this particular configuration, difference between VP and VN is multiplied by a constant number that forms your output. So V output, therefore, is VP minus VN. Okay, that's all there is to it. Now, this term A is called the open loop gain. Okay, typically in the order of tens of kilo, okay, to mega, okay, and the units are volts per volt. It's called open loop gain factor. So again, in the open loop configuration, we like to show the gain, open loop gain, as a term A. So 3-terminal device, operational amplifier, the difference between VP and VN is multiplied. That forms your output. That's all there is to it. Now, we're going to do all kinds of fun stuff. We're going to connect feedback, apply an input here, then apply an input here, so on and so forth. But the first principles of an op-amp, as you see here, are really, really straightforward. V output is a gain multiplied by VP minus VN. So in the next example, we are going to sprinkle some numbers, throw in some numbers, and understand how this op-amp functions. What are the limits of the operation amplifier, so on and so